Did you know that nature is pretty cruel? It's always about survival of the fittest. That's why all the organisms need all the help they can get in order to survive. Organisms will tend to develop their bodies in forms that will be advantageous to them. Structures will often play a role in their function. Let's go take a look and explore all the wonders of Mother Nature.
Look at this leaf. Its physical properties allow it to absorb optimum sunlight for photosynthesis. The leaf is flat, broad, and thin. These properties increase surface area and allow for maximum absorption of sunlight.
Sorry, didn't see you there. On a slightly larger scale, we now take a closer look at branches, which contain many leaves. Branches are cylindrical, which allows them to provide water, nutrients, and protection to the leaves of the plant. The cylindrical shape is imperative because it allows water to participate in cohesion and adhesion, which reaches a greater surface area of the plant. If it were a rectangular prism, there would be 4 surfaces rather than one curved one. So cohesion and adhesion wouldn't be as strong and efficient.
A good way to understand the structure-function relationship is by looking at the relationship between a lock and a key. The shape of the key is specific to the lock. If one was to change the shape of the key, it would not be able to open the lock. This example shows how the structure of something affects how it functions.
Another example where structure and function play a crucial role in biology is enzymes and substrates. Enzymes are used for practically anything, whether it's metabolism or catalyzing reactions, and the structure of them is extremely important. Substrates and enzymes are structured to mix with each other perfectly at the active site, which is right here. However, once the structure changes, it changes the function of the enzyme. For an example, if I take a marker and I make an allosteric site right here, that actually inhibits the working of the enzyme, which changes its function. So it really shows how the structure of the enzyme and making sure that the active site and the substrate are they can bind without being interfered is actually really important for its function and making sure it can carry out reactions.
The circular shape of tires is what makes them perfect for transportation. Because they have no straight edges, they are able to move in one fluid motion without any hindrance. Imagine if tires were any other shape. For example, a square. The car would not be able to move fluidly since the corners of the square would interfere with its motion.
Another example of how structure determines function is depicted in alpha and beta linkages. As you will see, the linkage of alpha glucose monomers in starch is different from the linkage of beta glucose monomers in cellulose. Alpha linkages link downward. So this is what starch would look like, but beta linkages link up, down, up, down. The difference in the structure of the two determine whether they can be digested by specific enzymes. Humans have enzymes that are specific to the alpha linkages in starch and therefore cannot digest the beta linkages in cellulose. This is important to the function of the two polysaccharides because in humans, starch is soluble fiber that can be used for nutrients, but cellulose, when ingested from plants like broccoli and kale, is insoluble and helps to clean out the lining of the intestines, but is not digested. Fun fact, starch and glucose are similar in the fact that they both have 1,4 linkages, meaning that the 1 carbon in one monomer is linked to the 4 carbon of the next monomer. This means that structurally they are both unbranched.